Hi, I wanted to make a quick little video that walks us through this Module 2 reality check assignment because I had some students send me questions on this. So it goes into polar ice caps and rising sea levels. And it says if it were to melt, the Arctic ice cap would release approximately 680,000 cubic miles of water. I want you to notice that that is in a unit of volume. And we're going to need that for part 3. So I highlighted that in green, and you can see here on my screen, I have a bunch of colors happening here so that I don't give away any answers explicitly. I'm just going to use colored boxes to represent answers that you find in one part that you might then use for the future, for next part in the problem. So this 680,000 cubic miles of water is a volume. And just to remind you about volume, here's a sphere. We have a radius. The radius goes from the center of the Earth to the edge. And so that's going to give us, we have a radius of about 3,960 miles. Well, the surface area is the outer part of this Earth. The volume is, and surface area, by the way, or any area is in units of square units because we have 2 dimensions, length and width. Volume has 3 dimensions, length, width, height. So it's in cubic units versus square units. And so it's important to note that as you do each part. And so don't get that confused with the fact that we're cubing. Cubic miles doesn't mean we're cubing. We're not raising the 680,000 to the 3rd power or anything. It's the miles that are cubic miles, and it's just a unit of measurement. So part 1 says we are going to use 3.14 as an approximation for pi. So don't use your pi button because that'll give you slightly different answers. But we are going to use this formula above, and we're going to practice plugging things into a formula. So we're going to take 4 and times it with 3.14 and times it with the radius that was given up here, 3,960, and that's going to be our surface area. And it's in square miles because it's an area, we call it square miles. That's our unit right here. So whatever you get, that's what I have as my yellow box. Down here to number 2, it says oceans cover about 71% of the Earth. So use your answer to question 1 to approximate the surface area covered by oceans. So this is the whole surface area of the whole Earth. If oceans are 71% of that, I like to write it out as a sentence first and then convert that into a mathematical sentence. We would say the ocean surface area is 71% of the Earth's surface area. When you take a percentage of something, the of word should be a clue, a keyword to you to multiply. And I'll tell you, I still have students in my college level math courses that forget this little step. And we deal with percentages out in the real world all the time. It's something that you should know as a life skill, I believe, is how to figure out a percentage of something. So remember, when we find a percentage of something, we should multiply 71% of the Earth's surface area. So 71% I'll write as a decimal. The of becomes a multiply. The Earth's surface area is what you got for part 1. So that's that yellow box there that you'll put right in there. And then the ocean surface area is a keyword for equals. So the ocean surface area, I'm going to call it, you can call it X, you can call it a blue box, whatever, is equal to 0.71 times the Earth's surface area. And that's going to tell you what 71% of the Earth's surface area is, which will give you the ocean surface area. Then you're ready for part 3. Part 3 says that the total rise in sea level in miles that would occur if the Arctic ice cap were to melt can be computed by dividing the volume of water. Now remember, the volume of water was given up here in green. That's why I highlighted it in green. We need that for part 3. So the volume of water, it says to divide that, dividing the volume of water that would be released by the surface area of the ocean. Remember, we just got that before. So that's my blue box here. So I'm going to take the volume of water that was given in the opening paragraph in green, and I'm going to divide that, or you can make a fraction out of that, with the surface area in miles. Once you do that, you're going to get a number, and that's going to be the rise in sea level, but it's going to be in units of miles because surface area or volume was in cubic miles, surface area is in miles squared. So when you divide them, you're going to get the rise in sea level in straight miles. And we don't want that. Notice it says, I want the rise in sea level to the nearest foot, not in miles, but to the nearest foot. So there's 5,280 miles in 1 foot. Sorry, other way around, 5,280 feet in 1 mile. And so whatever we get here for the rise in sea level in miles, we're going to go ahead and multiply that by 5,280 feet for every 1 mile. that does a conversion for us to change it to feet instead of miles. So we're going to get an answer here, and that'll be in units of feet. So it's the total rise in sea level in feet if the ice caps were to melt. Now we're ready to go on to part 4, because it says use a result from question 3. That's what I have here in pink. Whatever you got there is going to be this pink box here. And ignoring other factors, because there are some other factors where we've just really simplified it down for this problem. But suppose they melted completely over the next 200 years. So we're taking this rise in feet that would happen if they all melted, and we're going to spread it over 200 years, because we're saying, let's say they took 200 years at a constant rate. How many feet would it rise each year? So I want to take that number and divide it by 200, because that will tell me per year. I'm spreading it out over the 200 years for a constant amount each year. So when I make that division, I'm going to get this gray box. I'm going to get a number there. And that is the amount it rises per year. And remember, we're in units of feet. So we've kind of figured all this out down to rise of sea level in feet per year. Part 5 then tells us, let's make an equation out of that. Now that we know how much it's would rise in sea level per year, let's make an equation. So in terms of t, where t represents years. So you can write an f of x if you want, you can write a y. I just wrote words here. I said the sea level rise at time t is equal to this number, whatever you got for the gray box, times t. And that's really all it's asking for. Just let's write an expression, an equation that shows how sea level is rising based on time period. So let's say it was rising 1 foot a year, we would have 1t. And then we could figure out how long it would take to rise 13 feet, right? If it was 1 foot a year, it would only take 13 years. That would be an easy number to work with. You're going to get a different number than 1 there, but that's going to be right there. And so part 6 then tells you to take that and create some inequalities. Because San Diego is 13 feet above sea level, it says for what values of t would San Diego be safe? I considered safe to be the rise of the sea less than where the city is sitting. So here's the rate at which the sea is rising per year, per time period t. So I want to keep that less than 13 if San Diego is safe, and I'll solve that inequality for t and write my answer in an interval notation. And then New Orleans is even lower to the ocean. It's only 4 feet above sea level. So I would solve this inequality to figure out how much time New Orleans is safe. So I hope that was helpful. And I hope that helps you get through the project. Thanks for watching.